Welcome back. In the last video, we looked at some aggregation functions with using NumPy, such as getting the sum of all the elements in an array. We saw how much faster NumPy's code is to pure Python code when working on NumPy data types. So always use NumPy aggregation functions on NumPy arrays. And then we left off with a brief introduction to standard deviation and variance. Now, the main thing to remember about these two metrics is, in a word, they're just the measures of the spread of data. But let's not talk about it. Let's always focus on running code and seeing practical examples. So that's what we're going to do in this video. So we'll go demo of and var, standard deviation. STD is short for standard deviation. Var is short for variance. So we'll create high var array equals MP array, 1, 100, 200, 300, 4,000, 5,000. Wonderful. Low var array equals MP array. Maybe we'll make this one nice and simple, 2, 4, 6, 8, 10. There we go. Now, before we even run any code, have a look at the numbers in these arrays. Imagine these are actual data. What would you infer from just looking at these numbers? So this one starts from 1, goes to 100, 200, 300, then jumps to 4,000, finishes on 5,000. And this one kind of just goes 2, 4, 6, 8, 10. So first of all, you might look at the difference between the two maximums. That's what I kind of looked at. So this one goes from 1 to 5,000. And this one goes from 2 to 10. So if we looked at this, we might say that these numbers, to me, these are more spread out, whereas these are pretty close together, and the maximum distance is only 8, and they have the same step in between each one. Whereas this kind of varies. It goes up by 100 at a time, and then up by a few thousand, and then up by 1,000 to finish off. But let's put it into practice. Let's run the code. Let's see what's going on. So shift enter. Let's find the variance of both of them, high var, and we can press tab for autocomplete, MP var. We want tab for autocomplete. Oh no, we need to actually type the start of a variable. That would be helpful. Beautiful. We'll hit shift and enter. Now this is an absolutely massive number here, and this is not too big. Well, we're not going to look at the mathematics behind these two. What's more important is the concept here. And the variance, if we go up here, remember, variance equals a measure of the average degree to which each number is different to the mean. Higher variance equals wider range of numbers. Yep. Lower variance equals lower range of numbers. And that makes sense with these two arrays. This array here, high var array, has very high variance, whereas low array, because the numbers are close together, it has a lower variance. So let's have a look. Let's do standard deviation, STD. We want high var array, and we also want the low var array. We want standard deviation. Before we do this, what do you think the standard deviation is here? Is it going to come out similar to what this looks like? Well, let's have a look. There we go. And that makes sense. The standard deviation is higher for the high variance array than for the low variance array. And what is standard deviation? A measure of how spread out a group of numbers is from the mean. Okay, they've both got mean in their definition, so let's have a look. Let's find the mean. Dot high var array, and we want NP mean low var array. Higher var is not defined. This is why we should use tab autocomplete. So what this is saying is the standard deviation, this number here is the average distance a number is away from the mean. So if the mean is 1,600, that means on average, any other number in this array, in high var array, is 2,072 away from the next number. The same goes for the low var array. Any number in the low var array is on average 2.8 away from the mean. So that means 10 this number is, although it's 4 away from 6, because the mean is 6, 8 is closer to 6. So that's what brings the average down. All right, now let's check out this spread. Remember, that's the main crux of standard deviation and variance, is just the spread of numbers, how they appear. Let's plot them. So we can do that by importing matplotlib. We're going to have a look at matplotlib in a future section, so don't worry too much if you're not sure what's going on here. Matplotlib.pyplot as plt. That's what we want. Yep. Plot.hist. So this is a histogram. Hi. We just want that. Tab autocomplete. If in doubt, tab autocomplete. See what comes up. Shift enter. No module name matplot. Oh, we got that wrong. Matplotlib. There we go. Okay. So there we got the high var array. Now let's do the same for the low var array. Plot hist low var array. And we want plot.show. Wonderful. So now we can see visually, if you couldn't see it from these numbers in the number line here, now visually we can kind of see the spread of the numbers of high var array is a lot bigger. So there's a lot more white space here. A lot of the numbers appear towards 0, and only 2 of the samples appear up here. Whereas in our low var array, the spread is kind of similar across the whole thing because there's gaps of 2 between each data point, and the maximum distance here is only 8. All right, so that's standard deviation and variance in a conceptual level. Now remember, if you do want the mathematics behind this, how these two values here, the standard deviation and the variance, are calculated, I'll leave some extra resources, but just remember the main takeaway from this is that standard deviation and variance are measures of spread of data. Now, with that being said, we finished up some of the most common aggregation functions you'll see in NumPy. Let's get into the next section where we can check out some more ways of manipulating arrays.